All right, guys, I'm gonna need your A game today, and I know it's not ideal because we're not in where we usually are at, but a lot of people would consider this to be "quote unquote" the tough questions. We're gonna get the idea of antiderivative in, which is pretty much it's the inverse operation of a derivative, right? Like multiplying and dividing. So don't worry, we're gonna be fine. Say it again. Yeah, we're going to go in. Kind of. Yes. 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 So, and then don't worry. We're okay. So here we go. You guys ready? So let's just start. So I said before, let's chat a little bit of what an antiderivative is. So first, we're just going to get the derivative of all three of these. So I want you guys to notice. So I'm going to write y prime. What's the derivative of sine x plus 1? Cosine x. And I'm going to go to this one here, and maybe I should have called it a different letter besides y. Maybe I should have called it FG and whatever, but that's fine. Y prime, what's the derivative of sine x plus 10? Cosine x. And then I have sine x plus, I didn't count how many zeros on that. When I take the derivative of this, what do I get? Cosine x. So notice that the originals all differ by a, what do you think? What word? By a constant. And that's the one synonym that they're gonna. So that is even a word synonym. That's the word constant is the word that is gonna. I'll just say it. All antiderivatives differ by a constant because we don't know what the C value is. How do we figure out the C value? You got to give them an initial condition or a restriction to figure out the C value. Does that make sense? So we're gonna say if given that dy dx equals cosine x, that's the derivative of all of them, right? Then we would say, comma, then we would, that's a would, it's just the O and the U. We would say that y equals sine x plus c. So if given dy dx is cosine x, then we would say that y equals sine x plus c, semicolon, where c is a constant. So all three of them just differ by some constant. That's all. Cool or not cool? Cool. So let's see. Let's see if we can figure it out. So just like Ms. Cruz said, they give us the derivative, and we have to figure out what the original equation is. So we're going to do the inverse operation for the power rule. So what is the power rule? Remember the power rule? We take the exponent and we multiply it, and then we subtract by 1. Okay, reverse the order and the operation. So instead of, so what was the last move that we did? We subtracted by 1. So what's the quote unquote inverse operation of subtract by 1? Add 1. So I'm going to go, so here it goes. I'm going to go y equals, and I'm going to go 4x to the 4th power. And then what was the first move that we did with the power rule? We multiply by the coefficient. So what's the inverse operation of multiply? Divide. So I'm going to divide by whatever your exponent is, whatever you just added. Divide by 4. Do you guys see what I did? So put in there for good notes. Add 1 to the power, comma, divide by the power. Add 1, divide. And then what do I put after this? Plus what?
Oh, plus C.
Plus C. For some constant C. Yep. For some constant C. For me. Maybe your professor is going to want more. Is going to want you to say for some constant C all the time. And if that's so be it, then so be it. Did I say that right? If that is so, then so be it. Okay. There it is. All right. Are you going to leave it like that? No, you probably want to. So my function, the original, is just x to the 4th plus C. For some constant C. And then you just test it. Like, Chop, how do you test it? Take the derivative. Is the derivative of x to the 4th 4x cubed? There it is. You're right. You got it. How do you feel? Okay. Yeah, no yawning. Okay. I'm kidding. Yeah, it's not. It's not. It's not. Okay, check it out. It's not until this one here that we might have issues. We'll see. An object. All right, guys. Well, I don't think this is wood, but all right, here we go. Here we go. An object is dropped and hits the ground 3.5 seconds later. From what height in feet was it dropped? Okay, you guys ready? All right, so here's how I would do it. Start with acceleration. We know the acceleration due to gravity is 32 feet per second per second. From one height in feet. So you can say 9.8 if you 9.8 meters per second if it's set it in meters, but it's set it in feet, so 32 feet per second per second. That's the acceleration due to gravity. That's a constant, guys. Acceleration due to gravity, 9.8 meters per second, or 32 feet per second per second. Yeah. But now we have seen the light. Are we okay with the number 32? All right. I'm going to find out my velocity by doing an antiderivative that we just introduced right now. Right? So the antiderivative acceleration is velocity. Do you guys agree with that? Okay. If an object is dropped, the initial velocity is 0. So I'm going to go antiderivative acceleration of velocity. So I'm going to write v of t equals 32t plus c. But since the velocity is 0 at time 0, I guess I'll show it. Semicolon 0 equals 32 times 0 plus c. Semicolon c equals 0. Does that make sense, guys?
Oh, yes.
Where's the what? Antiderivative of 32. What's the derivative of 32t?
Okay, 32.
32.
But I'm asking, so the v of t is the original?
Yes.
And a of t is the derivative?
Of velocity, yes.
Okay.
Just for clarification, the D is the second equation, that's just for derivative?
There's no d.
What is that? Is that a 0?
Where? That's a 0.
Oh, just kidding.
So my velocity initial is 0. Right? Okay. Ask me questions, guys. Do we have any questions right now? Okay. By the way, I probably should have assumed that down is negative and up is positive. I didn't. They just want to know the height, so I'm going to take absolute value. If I would have taken positive and negative into account, when I do the antiderivative of this, I would have gone a negative value for the height because it's going down. I just deleted it and just, you know what I mean? Okay. It'll take into account in the next one. All right. So I want to know the position. So the antiderivative of velocity tells me my position. Are we still okay? Okay. I'm going to write h of t equals, what's antiderivative of 32t?
32.
No. Antiderivative. Add 1.
T to the 32.
Oh, wait.
Oh, no.
Add 1.
Wait, add 1, that's going to be t
What is it?
squared. 32t squared.
No.
16t squared.
Yes.
Boom.
Tell us what you did, Miss Cruz.
Okay, so we added 1, right? So it would be
There's a 1 right here.
32t squared, then we divided by 2, and it would be 16t squared.
Yes. She did this. I'll put the steps over here. She went 32t squared. She added 1. Add 1. And then we said we divide by 2. And 32. And then how do you check it? Take a derivative and see if you get 32t. 16 times 2, is it 32? There it is. And then technically I'm supposed to put a plus c here. But if I dropped it from the ground, if I dropped it initially, how much have I traveled initially? 0. So the c is 0. So this is my equation that will tell me how much I have fallen. Does that make sense? Do they give me a time for how much seconds later? So all I got to do is go h of 3.5 equals 16 times 3.5, close it squared. Does that make sense? Yeah, because your initial height was, we're assuming quote unquote is 0. You haven't moved. So I take my calculator. You need a calculator, and I know we don't have calculators, but yeah, you're gonna need a calculator for the rates quiz. There's no calculator in this room because they all took them for the SAT, PSAT. Okay, we'll just wait. Oh, I know what it's trying to do.
3.5. Or that's for the 3.5 squared. That's
Multiply by 16.
Oh, wait, no.
Okay, I got it, guys. Here we go. We're good. 16 times 3.5, close it squared, and we get 196. And I need units.
Feet.
Feet. No, just feet. Because this is how much you.
It's the height. Oh.
Because of these questions?
Yeah.
I have a video.
I was watching it.
Oh, no?
Yeah,
I was trying to.
But now it's making sense. Okay. All right. I need your A game for this one. I think you should just listen and then write afterwards, unless you want to. How do you think we should handle this one? Because this is going to be tough. Just listen.
I think whatever you think.
Okay, put your pencils down.
Yeah, I think listen and redo it with us following it again.
Yeah. So let's see. Give this question to winners. See if you can do it without. You can do it without calculus with a hack. You'll see what makes it difficult. We'll show you the hack. Because this one's tough, and we got to make sure that our answer that we get is the same one as that. All right, here we go. The answer is this one. We're gonna verify to see if we get that answer. A falling stone is at a certain instant 120 feet above the ground. Okay. 2 seconds later, it is only 40 feet above the ground. If it was thrown upward with an initial speed of 3 feet per second, from what height was it thrown? At first glance, it looks like you can just do this question with physics, with regular physics. What makes it hard is they don't tell you at what time it is at 120 feet. It just says at a certain instant. At some time, it's at 120. That's what makes it hard. So let's see if we can, let's write down stuff that we know. You don't have to write down, you can just listen. At a certain instant, it's 120 feet above. So I'm going to say h of t1 sometime is 120 feet. 2 seconds later, so I'm going to say h of t1 plus 2, and it is only 40 feet. Do you see what we did, guys? Okay. If it was thrown upward with an initial speed, so there it is. So that's my initial. So I'm going to write v of 0 equals 3 feet per second. 0 is the initial time, right? From what height was it thrown? Yeah, this is common notation. Sometimes they also call it v naught. So just to be ready, v0 is 3 feet per second. From what height was it thrown? So they want to know this h of t1 question mark. I know that all of them are related. The height, the velocity, and acceleration, they're all related. I can take an antiderivative from acceleration and work backwards to get my height equation. And then from there, we'll see from what height it was thrown. Really, they want the c value when t is 0. So don't worry. Let's. What do we know? This time I am going to say that down is negative, and up is positive, because this time the sign is going to help us out. We're still okay? Acceleration due to gravity, a of t, for any time is always, we're in feet per second here, or feet per second, 32 feet per second squared. 32 feet per second. Are we okay with that? So no one has issues there. All right. So I'm going to take the antiderivative of that. So I'm going to go v of t, which is the antiderivative of acceleration. What's the antiderivative of 32? 32 t. And by the way, if acceleration is negative, so I'll put a negative in the front and put a negative in the front. And then I put a plus c.
Wait, how is that going down?
Because acceleration due to gravity is going down.
How is the what do we find antiderivative of acceleration?
Yes.
Right, how is that 32t?
It's the antiderivative of acceleration. So the derivative of negative 32t is 32. Or negative 32.
Okay.
Are we okay so far, guys?
But then how come this one is 32 and the other one we had to make the whole 16t squared?
That's a position equation. I haven't gone to position. Right? Yeah. What's up?
I was going to ask, what would the c represent in this equation?
My initial velocity. Right? We're going to find it. Well, we already know it. What is it? 3. But let's go ahead and do good practice. Right now it's a simple to find it, but later on it might not be. So I'm going to say 0, because I'm doing it at time. Oh, not 0, 3. 3 at time 0 equals negative 32 times 0 plus c. So from there, do you see how c equals 3? So you didn't have to do that. I know some of you are probably saying, child, but I already knew that. Negative 32t plus 3. So if I plug in a 0 there, I should get 3, because I threw it upward. Doesn't it say I threw it up? It was thrown upward, and up is positive. So are we still okay? All right. Now I'm going to do the antiderivative of that. What is, because I want my position. Because I want to know from what height was it thrown. Do you know what I mean? All right, so here we go. I'm going to write h of t equals, what's the antiderivative of negative 32t? What's antiderivative of 3? No. Antiderivative. 3t plus c. Are we okay? Yeah, it's going to be quadratic. Kyle, what's going on? Tell me. Where's the what?
The C.
And when I take a derivative of a constant, it's 0. So that's why I don't have that's why I have to put a c. So when I take the derivative of this h of t, I better get the expression v of t. And I do, because if I have a constant, right? All right, guys, what we actually want to know in this case, you see how I have h of t1 is 120 and h of t1 plus 2 is 40? What I actually want now, let's think about it, and don't worry, I'm going to give you guys a chance to write a little bit. I want to solve for quote unquote c because what? Because h of 0 is c. That's what I want. I want to know from what height was it thrown. So at 0, I get my height that it was thrown at. Does that make sense? What's up? We're going to plug in this, and we're going to create a system. We're done with calculus. This is the last line of calculus. It's algebra. Last line of calculus. The rest is algebra, guys. You couldn't have done this question in physics because you didn't have calculus. If you would have done a hack, maybe, but all right, are we cool? All right, so here we go. I'm going to plug in T1 and T1 plus 2. So I'm going to go h of T1 is equal to, and I'm going to write negative 16 parentheses T1 close it squared plus 3 parentheses T1 close it plus c equals 120. I'm creating a system. That's my first equation. Second equation, h of T1 plus 2 is equal to negative 16 parentheses T1 plus 2 close it squared plus 3 parentheses T1 plus 2 close it plus c, and that one equals 40. By the way, these c's, put a subscript on them because those c's are the same. Later on I'm going to tell you that they're not the same, but right now those are the same value. They have to be. They have to be the same value. Are we okay so far? Nothing crazy, right? All right, we're done. Just do algebra. So let's distribute this guy right here in the second equation. Bam, bam. Well, I can't yet. I gotta just T1. I gotta expand this first. So let's expand equation 2. So negative 16 parentheses T1 times T1. T1 squared. Don't get it confused for the second isotope. What do you guys remember that from chemistry? Alpha and beta. Alpha 2,1, beta 0,1. Oh, then don't worry about it. Plus, if you're going into chemistry, let's not talk about that. T1 times 2 is 2T1, and how many of those am I going to have? So I'm going to write 4T1 plus 2 times 2, 4, plus 3T1 plus 6 plus C1 equals 40. Bless you. Are we okay so far? All right, I'm going to distribute this. So let's see, negative 16T1 squared plus 1632, 64. 64T1 negative. That's why I have you guys.
Isn't the 3t, aren't you multiplying 3 by tn plus 2?
Doesn't matter.
Oh, okay.
No, you're good. Ask, miss. Minus 64. I think we're good. Plus 3T1 plus 6 plus C1 equals 40. Okay, let's combine like terms. Bam. That's the only one. So negative 16T1 squared. Double. Negative 61T1. And then this guy, minus 58 equals 40. All right, what do I want to do? No, oh yeah, plus C1. Plus C1 equals 40. Are we still okay? Let's move the 58 to the right. So plus 58 plus 58. 16t1 squared minus 61t1 plus c1 equals what? 98. Okay, we're ready. Here's equation 1. That's equation 2. Equation 1 is negative 16t1 squared plus 3t1 plus c1 equals 120. That's fine. Do you guys see these two right here? I'm going to go ahead and subtract them, right? So I can cancel out the c1. Don't worry. We're going to solve for t1 first, and then, yeah. So I'm going to go ahead and subtract them. So here's what I have. So these are going to cancel. Are we still okay? And then this is going to be negative 64t1. The c's are going to cancel. And I'm going to have negative, is that negative 22?
Yes.
Are we still okay? Okay. Yeah. There we go. T1 equals 22 over 64, which reduces to 11 over 32. Are we still okay?
Yes.
Okay, now that I have this value, I'm going to plug it into equation 1 and solve for C1. Plug into equation 1 because it's easier. Solve for C. Because that's the value that we want. All right, let's see. I'm just going to plug it in, guys. Let's see. What am I going to do? I'm just going to put it in the calculator. I'm not even going to bother because when we have fractions. So tell me I have 120 and I'm going to subtract all this. So that's going to turn positive. That's going to turn negative. So look, I'm going to go 120 minus parenthesis. So I can just type it negative 16 parenthesis. What was it? 11 over 32? 11 over 32. Square it. Plus, I already forgot. Plus 3.
Just put 33 over.
I already started. No big deal. And I'm going to close it. Notice I already put 120 there, guys. 120 minus. So enter. And so there it is. That's the height. So it wasn't even much. Well, I guess it makes sense because you only did 3 feet per second. So yeah, it's only slightly higher than 120. Turn into a fraction. Math, frac, enter. Is that the fraction? Is that the answer? So C equals 7735 over, which is, what height was that? It was 120.859. 120.859 feet. So there it is. That's the height that it was dropped from.